Dear students, in this video I am going to explain about BFS. BFS means breadth first search. So basically it is a graph traversal technique. Graph traversal technique. Now see the first point. BFS algorithm produces a spanning tree as a result. That means whenever we apply this algorithm on a graph, so what you finally get is a spanning tree, right? Now, what is a spanning tree? Spanning tree is a graph with no loops. Okay, spanning tree is a graph with no loops. For example, consider this graph which is having four vertices, and when you apply this BFS technique on this graph, so what you get is a spanning tree. Now, for example, one of the possible spanning tree is this one. Okay, so this is a spanning tree. Now, as I told you, spanning tree is a graph with no loops. As you can see here, there are no loops, right? And also in a spanning tree, if there are n vertices, there will be n minus 1 number of edges. Okay. For example, here see how many vertices are there? Four vertices. We have four vertices. Now, how many edges are there? 1, 2, 3. Okay, so 4 minus 1 is 3. So, we are going to have 3 edges. So, you can call this as a spanning tree. Now, see the next point. We use the queue data structure to implement this BFS. So, in this process, we are going to take the help of a queue. Okay, and the last point, BFS is also used to determine the shortest path. Okay, now let's see the important part, that is the BFS algorithm. This algorithm is having 5 steps. Don't get scared by seeing this very big algorithm. I will try to explain this algorithm with an example. So once you understand the example first, then you can easily write the entire algorithm in your own words, right? Now see here. Now for this graph, I am applying the BFS algorithm. As I told you earlier, we require a queue for this, okay, and a normal array which is named as BFS. Now see the first point in the algorithm. Select any vertex as a starting vertex from the given graph and follow the below steps. So you can start the process from any vertex. I am starting from A. Okay. Now see the first step. Add it to the queue and consider it as visited. That means first of all add this vertex A to the queue and consider it as visited. That means now I am going to draw this cross lines to indicate that vertex is visited. So please note that when you see these lines here, red lines, it means that vertex is visited. Now see the second step. Explore the selected vertex. This is very important step. What is the meaning of exploring? See here, exploring means finding out all the adjacent unvisited vertices. Here we have two important words, finding out all the adjacent as well as unvisited vertices. So, for our vertex A, you tell me what are the adjacent vertices? B, F and G. These three are adjacent vertices. And also all these three vertices are unvisited, right? Now see here, mark them as visited. So you just mark them as visited, okay, and add them to the queue. So we have to add all these three vertices to the queue. In which order? You can add them in any order, okay? You can add BFG or GFB. The order is your choice, okay? The order is your choice. I am following the order B, G and F. Now make some indications that you have visited this B from A with the red line, okay? and also you have visited this G from A with a red line, and also you have visited this F from A by using this red line. Okay, now that is the end of step 2. What is step 3? After exploration, DQ the selected vertex from the queue and add it to the BFS array. That means now this is our selected vertex. A is our selected vertex. You just remove that vertex from the queue and add it to the BFS. So remember, two things you have to do for every vertex. Explore it, that is the first step. Explore it, and after exploration, remove it from the queue and add it to the BFS. Now see the fourth step. Select the vertex which is in the front of the queue. Now that means since A was removed, now we have B at the front of the queue. Okay, so now you have to select the B and repeat the steps 2, 3 and 4 until the queue becomes empty. So now select the vertex B. Okay, and now repeat the step 2, 3 and 4. Okay, what is step 2? Explore. What is exploring? Exploring means finding out all the adjacent unvisited vertices. Now see here, one of the adjacent vertex of B is A, but A is already visited. Okay, and F is also adjacent, but it is also already visited. Now look at this C here. C is adjacent as well as unvisited. So what you have to do is you have to add this C to the queue, add the C to the queue and mark it as visited and mark it as visited, and also indicate that you have reached the C from B by using this red line. Now exploration of B is completed. Go to step 3. Step 3 says that you just remove this B from the queue and add it to the BFS. Okay. Now the step 4 says that select the vertex which is in the front of the queue. That means now select the vertex G, and find out all the unvisited adjacent vertices of G. See here, A is already visited and F is also already visited. So exploration of G is over. Now what we have to do? Now we have to remove this G from the queue and add it to the BFS. Right. The next step, consider F. So go to F. So this is F. Explore it. Already G visited, B is visited, A is already visited, C is already visited. Now we have one vertex that is both adjacent and unvisited, that is E, right? So you just mark it by using a red line that you have visited E from F, and after that you mark it visited and add it to the queue. Now exploration of F is also completed. So remove it from the queue and add it to the BFS. Now consider C. Now this is C. So find out the unvisited adjacent vertices, that is D. So you just indicate that you have reached the D from C and mark it visited, add it to the queue, right? Now exploration of C is completed, so remove it from the queue and add it to the BFS. Now consider E. All the vertices are visited, so exploration of E is also over. So remove it from the queue, add it to the BFS. Now consider D. So this is our D, and for D, all the adjacent vertices are visited, so it is already explored. That means we have to remove this D and add it to the BFS. Now the queue is empty, so we have to stop the process. Now the last step, see here, to obtain spanning tree, remove all the edges which are not used for visiting. Okay, that means see here in this graph, you have to remove all edges which are not in the red color. Okay, so remove all these edges. So once you remove all these edges, now whatever you get here, it is a spanning tree. Now whatever you get here, that is going to be your final spanning tree. As I told you, one of the property of spanning tree is if there are n vertices, there will be n minus 1 edges. So count the number of vertices: 1, 2, 3, 4, 5, 6, 7. There are 7 vertices, and count the edges: 1, 2, 3, 4, 5, 6. Okay, that is 7 minus 1, that is equal to 6. There are 6 edges. So you can call this as a spanning tree. And whatever the order you got here, this is the BFS order. Okay, it is a BFS order. And also please note that there will be numerous BFS orders for a given graph. Okay, this is not the only BFS order. There exist numerous BFS orders. How can I say that there are numerous BFS orders? See here, at the beginning step, okay, while considering A as my vertex, what are the adjacent vertices? B, F and G, right? So B, F and G. Now in which order I have actually chosen? BGF. Okay, I have chosen BGF, but others might choose some other order, like here G, here B, here F. Otherwise, F here, F here, B here, G here. So depending on the order you choose, you will get a different BFS order. Okay, so please note that there exist numerous BFS orders, not a single order. Okay.